Hi, myself Dr. S.K. Bushra, former HOD, Department of Physics, Cotton University. This is a video lecture in physics for class 12 students. The topic is electrostatics. Lesson 6 of chapter 2, grouping of capacitors, problems. In this lesson, we'll work out a few numerical problems involving grouping of capacitors. Let's begin. Problem number 1. Using 3 capacitors, each of value 3 microfarad, how would you obtain a combination having an equivalent capacitance of 2 microfarad? Connecting 2 in parallel and the remaining 1 in series, as in the adjoining circuit, will get an equivalent capacitance of 2 microfarad. C subscript EQ, EQ stands for equivalent, is equal to C and C in parallel and another C in series with a parallel combination. So we have shown the C and C in parallel, then the other C in series with a parallel combination. Using the laws of series and parallel combinations, we proceed. C and C in parallel will give us 2C. Then C is in series with 2C. This is equal to, finally, 2C by 3, that is 2 microfarad when you substitute the value of C. Problem 2. Find the equivalent capacitance between A and B in a circuit below. That is figure 1. Given C1 equal to C4 equal to 1 microfarad and C2 equal to C3 equal to 2 microfarad. The given circuit may be redrawn as in figure 2. Then the equivalent capacitance between A and B is, here C2 and C3 are in series. With this series combination, C1 is in parallel, and with this combination, C4 is in series. Substituting the values, we get this next. Then carrying out the calculation as per the laws of groupings of capacitors, we have, and finally, C equivalent equal to 2 by 3 microfarad. Problem 3. Find the equivalent capacitance between A and B in the circuit below, that is figure 1. The given circuit may be redrawn as in figure 2. Then the equivalent capacitance between A and B is 2 and 2 microfarad capacitors in parallel. Then 12 microfarad capacitor is in series with them. And finally, 2 microfarad capacitor is in parallel with them. So following the rules of groupings of capacitors, we proceed. And finally, we get C equivalent equal to 5 microfarad. Problem 4. Find the equivalent capacitance between A and B in the circuit below. The last three capacitors of 3 microfarad each in the right are in series. They are together equivalent to C dash, where 1 by C dash equal to 1 by 3 plus 1 by 3 plus 1 by 3 equal to 3 by 3, which gives C dash equal to 1 microfarad. Therefore, the circuit reduces to the shown in the next slide. Now, the last two capacitors in the right are in parallel and equivalent to 2 plus 1 equal to 3 microfarad. Again, we have three capacitors, each of 3 microfarad in series in the right. Repeating the procedure, we end up with the equivalent circuit as shown, in which three capacitors of 3 microfarad each are in series. Therefore, the equivalent capacitance across AB is C, where finally C equal to 1 microfarad. Number 5. Find the equivalent capacitance between A and B of an infinite chain of capacitors connected as shown in the figure. The infinite chain will still remain infinite even if a cell is removed from it. For example, you may consider a cell shown enclosed by the red square in the figure. So if C subscript EQ, as before, EQ stands for equivalent. So if C subscript EQ is the equivalent capacitance between A and B, the equivalent capacitance between M and N, which are shown in the figure, will also be C subscript EQ. Hence, the equivalent circuit may be drawn as shown. Thus, C subscript EQ is C and CEQ are in parallel, and this parallel combination is in series with C. Proceeding further, we get C subscript EQ as given in the equation. Simplification yields a quadratic equation on C EQ, that is C subscript EQ. Solving the quadratic equation, we get C subscript EQ or C equivalent equal to half bracket start minus C plus minus under root C square plus 4C square bracket close. Since the capacitance cannot be negative, we omit the root with a negative sign before the radical. So we are left with C subscript EQ or C equivalent equal to C by 2 bracket starts under root 5 then minus 1 bracket close. Number 6. Find the equivalent capacitance between the points A and B in the circuit below. In the circuit, one plate of each capacitor is connected to A, while the remaining plates are connected to B. Therefore, the capacitors are in parallel. The equivalent capacitance is C equal to 1 plus 1 plus 1 equal to 3 microfarad. Problem 7. Find the equivalent capacitance between the points A and B in the circuit below. As in the previous problem, one plate of each capacitor is connected to A, while the remaining plates are connected to B. Therefore, the capacitors are in parallel. The equivalent capacitance is C equal to 1 plus 1 plus 1 equal to 3 microfarad. Number 8. Find the equivalent capacitance between the points A and B in the circuit below. Here also, one plate of its capacitor is connected to A, while the remaining plates are connected to B. Therefore, the capacitors are in parallel. The equivalent capacitance is C equal to 1 plus 1 plus 1 equal to 3 microfarad. Problem 9. Calculate the total charge and energy stored in the network. The equivalent circuit may be drawn as shown. The 3 microfarad and 3 microfarad capacitors are in parallel, and so are the 1 microfarad and 2 microfarad capacitors. These two parallel combinations are respectively equivalent to 6 microfarad and 3 microfarad. The 6 microfarad and 3 microfarad in series give 2 microfarad. Now, the 2 microfarad and 2 microfarad in parallel give the net capacitance of the circuit as 2 plus 2 equal to 4 microfarad. Therefore, total charge Q equal to CV equal to 4 into 10 to the power minus 6 into 100 equal to 4 into 10 to the power minus 4 coulomb. And the total energy stored U equal to half CV square equal to half into 4 into 10 to the power minus 6 into 100 square equal to 0.02 joule. Number 10. Find the equivalent capacitance between the points A and B in the circuit below. The two capacitors between R and S have been short-circuited. Moreover, the 3 in the left are in parallel. So, the equivalent circuit may be drawn as shown above. The 3 capacitors in parallel may be replaced with their equivalent C, where C equal to 3 microfarad. Therefore, the equivalent capacitance of the circuit is C subscript EQ equal to 3 by 4 microfarad. Subscript EQ means equivalent. Balanced Wheatstone bridge. Consider a circuit containing 4 capacitors as shown in the figure. Such a circuit is called a Wheatstone bridge. Now, if the condition C1 by C2 equal to C3 by C4 is satisfied, the points B and D of the bridge attain the same potential. Then, any capacitor connected between B and D of the bridge becomes ineffective. This is the balance condition of the bridge. Problem 11. Find the equivalent capacitance between the points A and C in the circuit below. The circuit is balanced Wheatstone bridge. So, the 10 microfarad capacitor between B and D is redundant, and the equivalent circuit is as shown. Along the path ABC, there is a series combination of 2 capacitors of 1 microfarad each, which equivalent is half microfarad. Similar is the case along the path ADC, with equivalent capacitance being half microfarad. So the final equivalent circuit consists of 2 microfarad capacitors in parallel. So the equivalent capacitance of the given circuit is half plus half equal to 1 microfarad. Problem 12. Find the equivalent capacitance between the points A and C in the circuit below. The circuit is a camouflaged balanced Wheatstone bridge. So the 1 microfarad capacitor between B and D is redundant, and the equivalent circuit is as shown. The problem reduces to the problem number 11, and so the equivalent capacitance between A and C is 1 microfarad. This brings us to the end of the lesson 6 of chapter 2. With this lesson, we have completed the topic electrostatics. We'll deal with current electricity from the next lesson. Till then, goodbye and thank you.